Hi students, welcome to online class. Yesterday we had discussed about magnetism. I hope all of you understood the topic. Yes. Today we are going to discussing the discovery of magnet. First I want to say that the magnet have two property. First property, it attract the small piece of ions towards it. Okay, and the second property, it always shows the north and south direction when it's swinging. Okay, so these are the two properties of magnet. So this magnet is invented or not? Yes, it is not invented, it is found. The first magnets were not invented but rather were found from a naturally occurring mineral called magnetite. Traditionally, the ancient Greeks were the discoverers of magnetite. There is a story about the shepherd named Magnus whose shoe nails stuck to a rock containing magnetite. See, this is our Magnus, okay, 900 BC attributes to Shepherd Magnus, who found nails of his sandals pulled out by rock atop Mount Adam, okay, and the right of Pinley the Elder 23 to 79 Ada or magnetite iron oxides as a common in magnesia, Tesla Grace. So, listen. So, what's the history of magnets? According to Lucan, magnetism was first discovered by a shepherd named that's Magnus, okay, as the Magnus, and who lived in Magnesia, Greece. Magnus was herding his sheep through a mountains. Suddenly, he noticed the ferrules of his stick and nails in his sandals got stuck to a rock. The iron in his stick and nails had become attracted to the magnetic rock. The stone was named as magnetite. After the name of the shepherd or the country it was found in. It was also known as a leadstone because of its attractive property. Okay. Magnetite is one of the three natural occurring oxides of ions. It gets attracted to magnets and can be easily magnetized to form a permanent magnet. Naturally, magnetized pieces of magnetite are called leadstone. Peoples from ancient Egypt started using magnets to play tricks by making objects of worship floats in mid-air by proper positioning of magnets. Elegants have it. The emperor from China used magnet to save his palace by constructing gates made of leadstone. The emeralds made of metal got attracted to the magnetic gates and prevented them from going any further. In his book, The Magnet, um, scientist William Gilbert has mentioned techniques of artificially making magnets from steel. He used three techniques by which steel can be magnetized permanently. Rub the steel needles with a block of leadstone along a particular direction, starting from one end and ending at other. Second, forging. Forging powered iron at a high temperature under strong magnetic force. And next, the third one is leaving a red hot iron bars to cool in Earth's magnetic field for 20 years. This method only had a theoretical basis and was not used for the purpose. In 1820, the concept of electromagnetism was discovered by Hans Christian Ørsted, who observed a deflections in the compass needle from magnetic north when the electric current from the battery he was powering his setup with was switched on and off. I hope you understand the discovery of magnet. Yes. So thank you. Natural and artificial magnet. What natural and artificial magnet? Did you hear this word natural and artificial magnet? Do you know about this natural magnet? No. Okay. Do you know about this artificial magnet? Yes. It is available in the market also. So see, first we are going to discussing this natural magnet. This is the natural magnet. This is a leadstone. What? Leadstone or magnetite. Is it clear? Leadstone or magnetite. So what does this natural magnet means? A material which occurs naturally and has magnetic property is called natural magnet. See, this leadstone that is occur in naturally and has magnetic property. So it is called as what? Natural magnet. Okay, clear? Only this magnetite or leadstone is the natural magnet. Okay. So a magnetic iron ore is quite common in many parts of the world. If it cannot be obtained locally, find a supply house that will provide it for a small cost. A piece of such iron ore is a natural magnet. Sprinkle some iron fillings or finely cut pieces of steel wool on a sheet of white paper and observe how the ore attracts them. Try picking up heavier things made of iron, such as paper clips or carpet tacks, etc. Bring the lamp of ore near a compass and observe. Do all parts of the lamp affect the compass in the same way? Okay. And next is artificial magnet. What? Artificial magnet. See, these are some artificial magnet. Bar magnet. This one is ring magnet. And next is this is the horseshoe magnet, this magnet, and magnetic needle and spindle shaped magnet is also there. Okay, so these are different types of artificial magnet. So what is this artificial magnet? It is made from human being, a substance to which properties of natural magnet are imparted by artificial means is called artificial magnet. Okay. Artificial magnets are different shape and different size. Is it clear? Yes. So these are artificial magnets. So where to find artificial magnet? Strong and useful artificial magnets for the study of magnetism can be obtained from old radio loudspeakers, from old telephone receivers, and from old automobile speedometers. Magnets can be frequently be purchased in the market and may always be obtained from the scientific supply houses. Artificial magnets are made in many shapes such as horseshoe, U-shape, and the straight or bar magnets, and the disc magnet, ring magnets, magnetic needle or spindle magnet. These are the some different types of magnets. So now you got idea about why we are making artificial magnets? Yes. So why we are using these artificial magnets in the machines? This is the reason they can be made very powerful, which is not possible in case of natural magnets. Okay, it is very powerful than natural magnet. And the second reason, they can be made very desired shape and size. Natural magnet having leadstone having there is no desired shape and size, but these artificial magnets having desired shape and size. See the shapes, different shapes of magnets. I hope all of you understood this natural and artificial magnet. Yes. Next, we are going to discussing magnetic and non-magnetic substance. What is this magnetic and non-magnetic substance? Any idea? Okay. See, magnetic substance means the substance which are strongly attracted by magnet or can be converted into magnet artificially are called magnetic substance. Okay, they are attract very strongly by magnet. Okay, these materials called what? Magnetic substance. Maybe sometimes this change to magnet also. Okay, iron, cobalt, nickel, these are some examples of magnetic substance. Is it clear? Next is the non-magnetic substance. What is this non-magnetic substance? Magnetic substance means it is strongly attracted by a magnet. Okay, sometimes it change to magnet also. So the examples what? The nickel, cobalt, iron, and the steels, their alloys. Okay, these are the magnetic substance. So non-magnetic substance, just opposite. The substance which are neither attracted by the magnet nor can be converted into artificial magnet. These called as what? Non-magnetic substance. Example, rubber, plastics. These attracting the magnet? No. Why? Because these are non-magnetic substance. Okay. Examples: chain wires, plastic, wood, and brass, aluminium, mica. These are some examples of non-magnetic substance. Is it clear? Yes. I hope all of you understood this topic. Yes. The last class we are discussed about what? Yes, magnetism. So magnetism introduction I given you and types of magnet. So and the magnetic substance and the non-magnetic substance also we are discussed. So today we are going to discussing the attractive property of magnet. So what does mean this attractive property of magnet? You know that the magnet having what the property that is attraction, it is attracting towards it. All the magnetic substance it is attracting towards it. So in your textbook there is given six or seven investigations. So today we are going to discussing the first investigation, that is attractive property of magnet. Okay, so you know that attraction is the basic property of the magnets. Magnet attract metallic objects like iron, nickel, and cobalt. Sorry, cobalt. So the attractive property: magnets attract other magnetic substance. This property can be demonstrated with the help of simple activity. Okay. So what are the materials required? I have one word, the magnet. Magnetic paste. Okay, and other things, see, one scissor, wax, okay, and paper, one plastic. See, now this magnet will attract of this old subject or not. Just check it once. Paper, it will attract? No. Wax, it is attracting? No. See, the scissor, it is attracting the magnet? Attracting? Yes. Plastic, it will attracting? No. Why? Why these plastic, papers, and this clay and the scissors, these are attracted? Why they're not attracting? Which one attracted? Yes, scissor, that's attracted. Okay, why? Because of this is iron. Okay, steel, otherwise steel. Okay, so the steel or this iron piece, these are what? Magnetic substance. So these other paper and the rubber and the this wax, these are non-magnetic substance. Okay. So the first property what? The magnet attract the magnetic substance towards itself. Okay. So this is the first property of magnet. And you know the magnet having two poles, that you knows that north pole and south pole. Okay, one magnet having two poles, that is north pole and south pole, and thus the poles having more magnetic power, that is attracting power, that you know that poles having more magnetic attractive power. Okay, more attractive power. Is it clear? Yes. So this experiment or activity demonstrates that power of magnet of attract ion pace. Okay, I hope all of you understood this topic. Properties of magnet. First property we have discussed about what? Yes, attractive property of magnet, and second one is the poles of magnet. Okay, so today we are going to discussing the third property of magnet, that is directive property of magnet. What is this directive property of magnet? Directive property of magnet. Any idea? No. Okay. See, freely suspended magnet always point north and south direction. See this magnet, it is freely suspended magnet, and this always shows the north and south direction. This property is known as what? Directive property of magnet. You think about not only the same this bar magnet, if any shape of magnet, okay, irregular shape also, it always shows the north and south direction. Okay, I think all are read that investigation 6.3. Yes, what that investigate? What do you understand about this investigation? Yes, the magnet always shows the north and south direction. Okay, what's the experiment? Yes, first of all, we need the materials, water bowl and water, wooden piece and bar magnet. Okay, and bowl filled with the water. Okay, and put one in our wooden block. Okay, and you know that the wooden block will be float. So just keep the bar magnet above the wooden block and keep it rest. Okay, don't disturb that. So after you can able to observe that this magnet that shows the north and south direction. Is it clear? Yes. Today we are going to see the another experiment of the same property. Okay, freely suspended magnet like that. So I have one bar magnet. Now I am going to tie this bar magnet with a thread. Okay, this magnet with a thread. See, now I tied this magnet with a thread. Okay, this shows the north and south pole. This is the north pole and this is the south pole. Okay, see, this shows the north and south pole of a earth. By this moving just to left and right, because this shows the degree of the geographical region. Okay, you know that the geographical region in the north and south, that is 11 degree, is 12 degree, that is depend upon the place. Okay, if a bar magnet is freely suspended till it, okay, till it will swing until its one end points towards the north pole of the earth and the other towards the south pole of the earth. Okay, so a freely suspended magnet comes to rest always in the north and the south direction, so we call it a freely suspended magnet. See, this is the north pole and this is the south pole. Okay, clear? Okay, so this free magnet, because it is free to move in any direction. Okay, it can able to move in any direction. It can able, now this is not moving, only this shows the what the north and south direction, but it can able to move what if any direction. If we turn the magnet by hands, that it points in direct another direction and then leave it, and we will see that after a while the magnet comes back to its earlier position and again points in the same north south direction. Okay, so the end of magnet which points towards the north direction, that is called as what? North seeking end or north pole of the magnet. Okay, and next is the end of the magnet which point towards the south direction, so it is called as what? South seeking end or south pole of the magnet. Okay, so it is only a freely suspended magnet or a freely pivoted magnet. Do you heard the word pivot? Yes, we learned this point, pivot, word pivot, in fifth class GSC, general science. That's a simple machine chapter. There is pivot point is there. What is this pivot point? Pivot point, see, now I am tying in the center of this magnet. Okay, center. So it is will be rotated from this center only. So that is what pivot. We have already learned this in simple machine. There is a pivot point. It will be rotate in a pivot point or fulcrum. Is it clear? So, which always comes to rest along the same direction, north south direction, even after being disturbed again and again. Okay, how many times you disturb this magnet, then also it will comes to rest in a if any direction. Okay, clear? See, okay, it will comes to the same direction, that is north and south direction. Okay, so the four major directions, that is the four major directions, that is the word north, south, west, and east. Okay, north, south, east, west. These are the four main directions, and so we can have four more directions also. What is that? Northeast, northeast direction. Okay, and northwest direction also. Northeast direction, northwest direction, and what? Southeast direction and southwest direction. These are the another four directions. So this northeast direction is the midway. Okay, this midway between the northeast point. Okay, northeast direction. That is what northeast direction, and next is the midway of the northwest. That is northwest direction, and midway of this west southwest is here, that is word southwest, and midway of the southeast, here it is the word southeast direction. You know, the sun always rises in the morning from the east direction. So if we stand facing the morning sun rising from the east direction with both the arms exerted on sides, okay, then our arms, left arms will point towards the north, and the right arms will point towards the south direction. Okay, did you understand the topic? Okay, thank you.